Welcome to Practice 51. This is on page 64 of your TABE workbook. This is about three-dimensional figures and nets, and you can use a calculator for this one. Lily prepares a paper craft for a birthday party. This net represents the craft. Use the net for items 1 through 4. So I'm going to take a picture of that so that I can refer to it. And let's look at number 1. What is the combined surface area of the 4 triangles? The area of a triangle is 1/2 BH. So let's look at this triangle. We have 4 of them in this net. There's 1, 2, 3, 4. So whatever I get for my area, I need 4 of those. And here's the formula. Area equals 1/2 BH. So we don't know the area. We're going to find that 1/2 base times height. Well, the height of this triangle is 4 inches. So I'm going to go ahead and put that in for 4. And then the base of this triangle is right here. So that is 6 inches. And here we go. I'm going to keep my 1/2 for just a minute. I want to show you a little trick here. 6 times 4 is 24. What is half of 24? 12 square inches. You can also do a fraction on your Casio of 1/2 times 24, or you can do 0.5 times 24. But 12 square inches is for one triangle. So I have 12 on this one, 12 on this one, 12 on this one, and 12 on that one. 4 times 12 is C, 48 square inches. Number 2, what is the total surface area of this net? Well, we found our triangles, so let's take a look at this base. The 6 by 6. And you know how to do the area of a square. We've looked at that in our memory pieces. So the area of a square is S to the second power. So A equals side. That's one side is 6 to the second power. That means 6 times 6. You could also think of that as length times width if that's easier. So this is 36 square inches. So this is 36, this is 12, this is 12, this is 12, and that is 12. They want the total, so that is adding up all of the pieces of the net, and that is 84 square inches. You add up 12 plus 12 plus 12 plus 12 plus 36 is 84. Number 3, Lily arranges crafts for 8 children. So 8 kids are coming to this party. How much paper does she use for 8 nets? So we have 84 times 8, and you can use your calculator. That is 672 square inches. Number 4, which 2 of these best describe the net? Is it a cube? No. A prism? That's a box. A pyramid? Yes. Does it have a square base, a triangular base, or a rectangular base? It has a square base. If you fold this thing up, you would get a square pyramid. Number 5, we have a question. I started to say a new net, but we don't. Tim makes a clay cube. The edges of each face are 7 inches. So I'm going to stop right here and draw a cube, or try to. Bear with me. Put the two together and then connect your vertices. And I am going to enlarge this just a little bit so we can see it. Pull it right over here. And it tells me that the edges of each face are 7 inches. So regardless of where I look on this cube, it's 7 inches. That's what makes a cube. After removing it from the kiln or the oven, one face falls off the cube. So what's happening here? We're going to say when he brings it out of the oven, something went wrong. And one of the faces falls off. So maybe this face drops off. That would be what happened if I made this. I can imagine what it would look like. What is the surface area of Tim's broken cube? Use the formula surface area equals 6s squared. Now let's think about this. The cube has 6 square faces. Okay, that's where that 6 is coming from. But one of Tim's falls off. So how are we going to deal with that? Are we going to subtract it from the 6? Or are we going to subtract it at the end? Let me think a minute how I want to... let's just go ahead and subtract it now. I think that's going to be easier. This is for a whole cube. The surface area of Tim's broken cube is 5 faces times the area formula. So the surface area of the broken cube is going to be 5 times side, that's 7, to the 2nd power. Now remember your order of operations. Exponents come before multiplying. So 7 times 7, that's 49. And then 49 times 5, use your calculator. 5 faces times 49 is going to be 245 square inches. You could have found the whole cube, the 6 times, and then subtracted out the 49. That would work just fine. That's what I was debating, which is the better way to show you. But this is the way I would do it. I would go ahead and subtract out that face and then just work the formula. Number 6, we have a new net. So let me take a picture of that one. And we will take a look at this. What three-dimensional figure can be made by folding that net? If you folded it up, it would not be a cube because the sides are not even. It would not be a square pyramid because there are no triangles involved. It's a rectangular prism. It's a box. It could not be a rectangular pyramid because there are no triangles involved. So number 6, it would be a box if you folded it up. Number 7, what is the combined surface area of A, faces A, and C? So let's take a look here at face A. That's this one. And then face C is identical to it. We call that congruent. They are exactly the same. A is 7, and this dimension is 3. So I'm going to do the area formula, which is length times width. So the area is 7 times 3, and that is 21 square centimeters. That's for A. That's also true for C. Combined means to add. So you want D. 42 square centimeters for A and C. Okay, number 8 wants to know the total surface area of this net. So let's take into account what we already know. We know A is 21 and we know C is 21. B and D would also be 21. So we have 4 of the 21s. A is 4 times 21. Plus, we have to deal with these two little sides. The sides of the box, which would be E and F. Those are congruent. E is not labeled, so let me work with F. We have A equals, that's a square, so it's S to the second power. A equals 3 to the second power. That's 3 times 3, which is 9 square centimeters. And we have 2 of those. We have this one and this one. So 2 times 9. 4 times 21, we already know that one. No, we don't. Sorry, we did 2 of them. So we have 84. And then 18 for the 2 times 9. So the net area, the whole thing, is going to be, what, 102, maybe? I'm doing this in my head. That's dangerous. Let's see if that's a choice. Yes. Number 8, the total surface area of this net is B, 102 centimeters squared. Number 9. It says to use this net for 9 and 10. So let me make a copy, just in case. What three-dimensional figure can be made by folding the net? A triangular prism, a rectangular prism. I can rule that one out because there are no triangles in a rectangular prism. A triangular pyramid, or a rectangular pyramid. This one's a little tricky, especially with the triangles. You have to visualize where those triangles would be when this is folded up. And it's A. This would be a triangular prism. Number 10. The height of the triangle is 3 meters. What is the total surface area of the figure? So let's zoom in here and really focus on our picture. We have 2 of our triangles. We have, be careful, we have a 5 by 8 rectangle. And here's another one. We have 2 of those. And then we have this square, an 8 by 8 square in the middle. So I need to calculate these areas and put them together, add them together. And I'm going to try to squeeze them in right here. This one I know I can. The area of a square is s to the second power. So that's 8 to the second power. That is 64 square meters. The area of a rectangle is length times width. So the area is 8 times 5. The area is 40 square meters. And I also have that over here, 40 and 40. The area of a triangle is A equals 1/2 BH. So I have 1/2 times base. We know the height is 3. So the question we have to think about is how much is this distance right there? And that is 8 meters. Whoa. 8 meters. So I'm going to say, I always leave my 1/2 for now. 8 times 3 is 24. And half of 24 is 12 square meters. So we have 12 and 12. So to get the total surface area, I have surface area is 2 of the 12s plus 2 of the 40s plus that 164. So I have 24 plus 80 plus 64. And then I ran out of room. I'm not even going to try because I'll have it all messed up. Let me just squeeze it in there. Add those up. 24 plus 80, that's 104. Plus 64 is 168 square meters. So I like D for this one. Number 11. Thomas ships a crate that is a cube. The width of the crate is 3 feet. He must wrap the entire surface area of the crate in plastic. What is the surface area of the crate using this formula? I'm not even going to draw this one. As much as I want to, I'm not, because I want you to see that we can do it without a picture, even though I don't want to. I like pictures. The width of the crate is 3 feet, and it is a cube. So the surface area is going to be 6 times the 3 feet to the second power. Exponents before multiplying. 3 times 3 is 9. 6 times 9 is 54. So he is going to need 54 square feet of plastic. Thomas has 50 square feet. Excuse me. I knew I was going to sneeze. Thomas has 50 feet of plastic, 50 square feet. Which statement is true? He has 50. He needs 54. So does he have enough? No. Thomas needs an additional 4 feet, square feet of plastic. So for number 11, part A is C, part B is C. Number 12. What three-dimensional figure can be made by folding this net? Those are all squares, so if you fold them up, you are going to have a cube. A cube has 6 square faces. You could cut out, I'm not recommending that you cut up your workbook, but you could cut that figure out and fold it and make yourself a nice cube. 12A. Number 13. What is the surface area of this figure? You know how to do this. You have 4 triangles. And what's that middle shape? It's a square. This would make a square pyramid. Triangular faces make a pyramid. Rectangular faces make a prism. So I need to do the 4 triangles, and then I need to work with this square. I think I'm going to do it first because it's the easier formula to do. The area of a square, A, is S to the second power. So A is 9 to the second power. That's 9 times 9. That is 81 square yards. Then the triangle is 1/2 base times height. 1/2. The base is 9 and the height is 8. So 1/2, 9 times 8, that's 72. Half of 72 is 36. Or you can just multiply that all through. That's fine. So 36 here, 36 here, here, and here. So surface area is 4 times 36 plus the 81. Parentheses first. So that's 24, 12, I believe that's 144 plus 81. Add those together. Guys, it's dangerous. I'm doing this in my head. I believe it's D. 13 is D. 225 square yards. And last but not least, what is the surface area of this figure? Okay, let me color this one for you. I have the top of this box and the bottom of the box would have to be congruent. Here's the bottom. Or, I'm sorry, those would be the sides. I don't know what I'm talking about. These are the left and right sides of the box. Here's the top and the bottom. They would have to be congruent, but I had the wrong. This would be the bottom of the box. And then this would be the top when you folded it up. Okay. And then we have the 2 side pieces, which are congruent. Reason I'm coloring this is so that you realize which pieces match and which pieces don't. These are not the same all the way through. You can't just find one and multiply it by 6. Okay, the easiest one to see is right here. I have length times width, and that's going to be 6 times 5. So that area is 30 square meters. And so is this one. Okay, the yellow, this is 6 meters, and this is 4 meters. So the area would be length times width. That would be 6 times 4. which is 24 square meters. That makes sense that 24 is a little smaller than 30 because that yellow is a little smaller than the blue. All right, then these pieces that are hanging out to the side. Let me think a minute, guys. I've done something wrong, I think. Or maybe I just feel like I have. I guess not. I started to ask you if you see anything wrong, but okay, let's look at the red ones. If I've done it, maybe I'll find it here in a second. Okay, the red, I have a 4. We've got the 4 meters. And then this piece is going to be the 5 meters. So this one is area is length times width. Area is 5 by 4. So area is 20 square meters on that one and 20 on this one. So I have 2 of the 30s plus 2 of the 24s plus 2 of the 20s. And this is not area, that's surface area. So we have 60 plus 48 plus 40. So that looks like 148, I believe. I still feel like I've done something wrong, but sometimes I just get that feeling. So let's check this one against the answer key. I believe it's A. And yes, it is. So I guess I didn't do anything wrong. I'm tired. So sometimes I just think I have and I really didn't. And then sometimes I've blown the whole problem. All right, that brings us to the end of practice 51. I believe our next one is a review and then the end of our workbook. So we are finished almost with another workbook. I will see you very soon for that next lesson, and I hope you have a really good day. Bye-bye.